Welcome to the 2D to 3D mapping section of our test. In this segment, you will see a 2D representation of a 3D shape, and your task is to visualize how each 2D representation can be folded along the dotted lines to accurately construct the 3D shape. So again, you will start with a 2D representation of a 3D shape, and that's what we see here on the right. This is a practice level example, so a little bit simpler than what you'll see on the test. In the top portion, we can see the first image, which is the 2D representation. And below it, you can see the corresponding 3D shape. You'll also notice that the 2D representation includes numbers, and those numbers go along with these dotted lines, whereas the 3D shape includes letters. Now in this case, we have the same number of numbers as we do letters. In the 2D representation, we have numbers 1 through 5, so 5 numbers. And in the 3D shape, we have letters A through E. So again, 5 letters. But again, this is a practice level example. It's a little bit simpler than what you'll see on the exams. And most of the time, you'll actually have more letters than you do numbers. So you cannot rely on a simple process of elimination. You'll also notice that both images, the 2D representation and the 3D shape, will include a matching face which is indicated by an X. And this is to help orient yourself during the mapping process. So here you can see the X in the 2D representation, and you can see where that X corresponds in the 3D shape. So these are the same faces. And again, this is used to orient yourself. And again, the goal of this exercise, of these problems, is to determine which numbers correspond to which letters. So for example, is 1 A? Is it B? Is it C? And so on. There is one letter per number. So we said that the first example we saw on the previous slide was a practice level example, and that the test level questions would be a little bit more complicated. And you can see an example of this here on the right. We can see that we have a much more complicated 2D representation and correspondingly a more complicated 3D shape to construct. Now you'll also notice, again, unlike the practice level example, we have more letters than we do numbers. So again, you cannot rely on a simple process of elimination. So the way that you will solve these problems, or that each person solves these mapping problems, will be a little bit different, but there are a few steps that you can follow to help you create a grounded approach. The first is to simply check if there are indeed more letters than numbers. Again, in most of these test level questions, you will have more letters than numbers. But in some cases, like the previous practice level example, you will have the same number of numbers as letters. With that known, the second step is to mentally rotate the models to align their orientation. And again, you'll do that using the two X's. Now, what do we mean by this? Well, typically, the 3D representation will be rotated with respect to the 2D representation. So in your mind, mentally, it's best to rotate one of the two images so that they are oriented. The third step is to solve adjacent numbers first. So what do we mean? Well, for example, in the 2D representation, we see 1 and 5. These are adjacent. These two numbers are next to each other. So you should solve these in pairs, because when you orient yourself with one number, or rather you answer one number, you match it to the corresponding letter, it makes it easier to match the next number. So you don't necessarily have to go 1, 2, 3, and so on. You can choose the order based on how the numbers and letters are laid out in the two different images. And the last tip or last step is to simply check your answers. This is always a good idea, but it's especially a good idea for these mapping problems, because you may feel confident in your answer when you first choose it, but after supplying more answers, you may catch an error more easily because something may be inconsistent. One answer may invalidate or reveal that another answer is incorrect. So now let's work through a guided example. So here on the right, we see what we've seen previously. We see a 2D representation along with its corresponding 3D shape. Now let's again point out the key features. We have the X on the 2D representation, and we see that same X on the 3D shape. We also have the numbers in the 2D representation, and we have letters in the 3D shape. And again, your goal is to determine which letters correspond to which numbers. So for example, here we have the number 1 on this side next to the X, and your goal is to say which of the letters in the 3D shape correspond to that number. So let's start by just writing a place to write our different answers. We have 5 different numbers, so we're going to have 5 different answers. And those answers will again be in the form of letters from the 3D shape. So now let's take a closer look at the 2D representation. We'll start with number 1. Here again, we have number 1 on the side that's just next to the X. So what do you notice about the 2D representation compared to the 3D shape? Well, they're actually slightly rotated from one another. In the 3D image, we are looking at the X straight on, but in the 2D representation, it's essentially rotated by about 90 degrees. So if we want to look at the X in the same way we're looking at it in the 3D image, we'd be looking from this perspective here. So with that said, when you fold across this dotted line, which is what's relevant for number 1 here, this portion will come forward like so. And in doing so, this number 1 will be on the left side of the X. It will be on the edge to the left of the X in the 3D image. So which of these in the 3D image corresponds? Well, that would be C. Here we have the letter which is to the left of the X, as we've just described. So number 1 will be C. Now what about number 2? Number 2 is essentially opposite number 1. Now this is where it can get a little bit trickier, because we don't have as much help from the orientation with the letter X. But we know again, number 2 is opposite number 1. So when we fold this portion up, again, we're using the dotted lines to determine where we are folding. Well, when this folds up, that means that 2 will be on the opposite side as the X, and from this perspective, looking at the X from the front, as we see in this 3D image here, that means that number 2 will be on the left side of the X, just as number 1. Again, you can see number 1 is on the left, and therefore number 2 will also be on the left, but on the opposite side. So that corresponds to letter A, and therefore 2 will be A. Now what about number 3? Number 3 is again a little bit more different still. In this case, it's not on the same side as the X, it's not on the opposite side as with 2, but it's actually on the adjacent side. So if we look at our 3D image and we search for number 3, again, we're imagining that this folds up according to this dotted line here. So we should expect that this is present here on this face, this side of the cube of our 3D image. Now, because 3 will fold up, it's going to be on the top edge. So by top edge, I mean, for example, here B, this is a bottom edge. This is on the base of the cube. Now, the top edge would be the opposite, here, with E. So therefore, E corresponds to number 3. So that leaves 2 more. We have number 4 and number 5. And of course, we'll start with number 4. So number 4 is using the same dotted line, or we're considering the same dotted line as we considered for 3. That will fold across this dotted line, and this face will come up. So again, we're referring to the same face of the 3D image, the same face of the cube, as we cared about for number 3. But in this case, it's simply the opposite. If 3 was the top edge, well then 4 is going to be the bottom edge, and therefore the corresponding letter is B. So for 4, our answer is B. And then we have one more. We have 5. Now 5 returns to the first dotted line that we cared about here, which was relevant for thinking about number 1. And we said that number 1 is C. So if number 1 is C, we're looking for the edge that is at the base of the X. So you can see 5 here is on this dotted line just below the X. So if we look for that in our 3D representation, that would correspond to D. Now again, if we refer to our previous answers, just to make sure everything is consistent, we said that number 1 was C. So therefore, number 5 on the dotted line will be D. And again, you can see where these are with respect to one another to make sure that all of your answers are consistent. And indeed, they are. So number 5 will be D. So it's always helpful to have an animation so you can actually visualize how this transformation from 2D to 3D or 3D to 2D is taking place, rather than only relying on your imagination. So here we have such an animation, and it will be going from the 3D image, exactly what we see in the bottom right, to the 2D image there at the top right. So let's go ahead and take a look. So again, the animation starts with the image, exactly as we see in the bottom right here in the guided example problem. And the first thing you'll notice is that 90-degree rotation will take place. This doesn't actually change anything other than the perspective. Now then you'll see that the cube starts to essentially unfold, and there's a few key points to notice. You'll see that each face of the cube will actually unfold and make contact with the ground you can think of. It's a 2D image, so therefore we only have length and width. We only have 2 dimensions to work with, and therefore every face goes from the 3D to the 2D plane. Now, the only other face to consider is that top face of the cube. That top face will also come down from the 3rd dimension to the 2nd dimension and be in line with these other faces of the cube. So we'll go ahead and let that play a little bit further. So again, the animation has the labeled correct answers we just discovered in the previous slide. So you can see number 1 here corresponds to C. And if we refer to our 3D image here, you can see C is to the left of the X. Now in the 2D image, take a look how this looks. It is also to the left of the X, if you are looking from the same perspective. Remember, this was rotated 90 degrees. So if you are looking straight on, facing the X, as you do in the 3D image, this C is again to the left of the X. And you can apply that same thinking to all of the other numbers. For example, we can consider 2 here. 2 we deemed is A, and again, you can see that here. It's on the opposite face of the X. Here we have the X, here we have the opposite face, and it's on one of those edges. And if we look at our 3D image here, we can see the A. It's an edge that's a part of the opposite face, and it's to the left of the X when you are looking straight on the face where the X is labeled. So now that we've gone through a practice level example, let's go through a second guided example, but this time of a test level question. And we'll do this a little bit differently. Instead of first solving the problem and then reviewing the animation, let's take a look at the animation first so it's easier to follow along with the explanation. So here we have our animation. We first see that rotation step before we see the transformation from 3D to 2D. You'll see this unfolding. You'll see all of the different faces of the 3D shape enter the 2D plane until we have our final 2D representation. So let's take a look one more time. One thing that makes this easier or makes these animations more helpful is to pick a particular point and follow it from beginning to end. So that can be the X, or it can be one of these labeled edges. If you try to see every point in the shape going from 2D to 3D or 3D to 2D, it's just going to be too much to visualize. So pick one particular point and follow it along, and you can always watch the animation again and repeat until you have a good mental model of this transformation. So again, let's take a look. Here we have that rotation, and let's follow the X, for example. Here we have the X facing us. We see the unfolding where the X enters the plane first, and then again, all of the other faces will also enter the 2D plane until we see our final representation. Now, one other important thing to notice is above the X, or to the left of the X, depending on your perspective, you can see this pyramid-like shape. You can see how it looks in the 3D animation, again as a pyramid-type shape, and then how it looks after the unfolding once it's in the 2D plane. So this is going to be an important element to help answer this question, which we can do now. So first of all, are there more letters than there are numbers? Yes. And again, this is typical of these test level questions. But how many numbers are there? There's 5. So we will have 5 answers with 1 letter each. So let's start by writing a place to write our answers, our 5 different answers. And then let's look for adjacent numbers, or numbers that are next to each other. So in the 2D representation, we can see 3 adjacent numbers. We have 4, 5, and 2. These are all associated with the same face, and to make our lives even easier, they're actually all associated with the face with the X. So we should start with these 3 numbers. So again, here is our X in the 2D representation, and here it is in our 3D image. We're looking for 3 different letters for our 3 different numbers, but we can see in the 3D shape, we actually have 5 different letters. We have H, A, G, D, and B. So let's start by eliminating 2, and then we can match the other 3. Well, the first obvious one to eliminate is A, because we see that A is associated with this pyramid structure here. And in the 2D image, this element can be found here. And we see that we have no numbers associated with it. In the 3D image, we can see A. And if A were to be labeled as a number in the 2D representation, we would expect to find it here. It's above the X, and it's at the base of this pyramid. But we don't see that, so we can eliminate A. Likewise, we can eliminate D. D is to the right of the X in the 3D image. And if we look at our 2D representation, if we look to the right of the X, we don't see we have any numbers, so we can eliminate D. So this leaves 3 different letters. We have H, G, and B. So which is easiest to identify first? Well, it'll be B, because we see that there is only 1 letter below the X, and there is only 1 number below the X. So that means 5 must be B. This leaves 2 other letters. We have H and G. And in our 3D shape, we can see that these are to the left and to the right of this pyramid, or again to the left or the right of this X. So returning again to our 2D representation, that is between 4 and 2. And we see that 4 is to the left of the X, whereas 2 is to the right of the X. And this will be true even after the transformation. This will fold up like so. So again, 4 will be to the left of the X, and 2 will be to the right. So what is left and right of the X in the 3D image? Well, we have H to the left of the X, and we have G to the right of the X. So therefore, 4 is going to be H, this is to the left of the X, and 2 is going to be G, again, to the right of the X. So just like that, we have 3 of the 5 answers done. We have 2 more. We have 1 and 3. So which is which? So let's start with 3. We see 3 is not associated with the face with the X. In fact, it's going to be essentially on the opposite side, because again, this is going to fold up like so, this face with the X, and this opposite side will also fold up like so. So because of that, we can see that we basically have 2 options. There's 2 letters that are on the opposite face or associated with the opposite face as the X. We have F and we have E. But which is which? Well, again, 3 is to the left of the X, and F is to the left of the X. So therefore, 3 will be F. And that leaves 1 more. But again, there's more letters than numbers, so it's not a matter of process of elimination. Let's take a look more closely. We have 1. Again, 1, like 3, is not associated with the face with the X. So where should we look? Well, it's to the right of the X, so we should look for it here on the right side of the 3D image. So what are our options? We already eliminated D. We already said that E is not correct because 3 was F, so that leaves only 1 option. It leaves C. So therefore, C will be the answer to number 1. And indeed it is. This 1, this edge here, is associated with the face that is in the base of the 3D image. So again, we have our answers. We have 1 is C, 2 is G, 3 is F, 4 is H, and 5 is B.